is what we're working on today. But let's do a little review here first. Find the value of the variable, simplify any radical. All right, we got this. So I'm taking a look here at number 1. Now notice, I had some kids on the quiz be like, oh, I'm gonna just make this a 30 and a 60. No. You can't just add in the angles. You have to work off your given picture. You're finding the sides. I don't know if it's a special right triangle, so I can't use those shortcuts. I'm gonna just use my old school Pythagorean theorem. Now, of course, it's important you identify your hypotenuse straight across from the right angle. Same, we're gonna have hypotenuse a lot today. And again, I'm gonna start with x. I'm gonna do x squared, 8 squared, 15 squared. Obviously, you need your calculator for the, well, probably not for 8 squared. We know that's 64. Anybody know 15 squared off the top of their head? 225. All right, I'm gonna let you take it from there. Subtract your 64. What's 225 minus 64? I like that. You might not like it, but I like it. I know you guys know the square root. Here's why I like it. The square root of 161, I'm kind of trying to be nice to you, actually doesn't simplify. 161's prime, so bam, I'm done, okay? So I'm going to just leave my answer square root 161. The simplifying of the square roots on the quiz yesterday was really, really impressive, so I'm not too worried about that. All right, same thing. Let's take a look here at number 2. Now, this one I like. I could do Pythagorean theorem. X squared plus x squared equals 30 squared. That seems like a lot of work with those big numbers, 30 squared. Also, if you have 2 congruent sides, what do you know about the angles? Yeah, 2 congruent angles. So they're going to be 45, 45, 90. So this is a 45, 45, 90 kind of in disguise, so to speak. So if I want to find the congruent sides, and you know your hypotenuse is 30, I'm going to give you a 50-50. Do I times by the square root of 2 or divide by the square root of 2? Divide. And now we cringe a little because we can't have a radical on the bottom. We're going to rationalize the denominator. So much good stuff here. So of course on the top I've got my 30 square roots of 2. You guys are great at the denominator. I saw a lot of people skipped writing square root of 4. I would too, because what's the square root of 4? Let's just make our lives easy. Is there anything else you could reduce on this? 30 and 2. So 30 over 2, I'm going to make it 15 square roots of 2 for my sides. So that's just kind of a little twist on a 45, 45, 90, just in disguise. Now, again, what we're working on today, what if it is not 45, 45, 90, or 30, 60, 90? We're going to use what's called trigonometric ratios. It's going to sound like a foreign language, but I promise you, this is actually pretty easy. So, a few things you got to fill in on the blank. A trigonometric ratio. Do we have a spelling test on trigonometric? Say it fast 5 times. Okay, remember ratio, fancy name for a fraction. So we're going to have some fraction answers today. So it's the ratio of the length of 2 sides. So you are comparing 2 sides on the triangle. I'm going to have 2 side lengths in my fraction today. You'll use trigonometric ratios to find the measure of a side or an acute angle in a right triangle. It has to be a right triangle. Everything this chapter is a right triangle, let's get honest. We will show you in the next chapter, if it's not a right triangle, how you can find the sides and angles, but that's another chapter for another time, okay? So we're gonna have some fractions. It's gonna look like a foreign language. Let me explain. So we're gonna use that sine, cos, and tan. So you do need to fill in these fractions on your notes. Now again, you'll see I abbreviate a lot, and you can too. Like for opposite, you could just put OPP. You'll see me write that a lot. Hypotenuse. So you're welcome to abbreviate those also, okay? Cosine. Now, same thing for cosine. I'll abbreviate it. Adjacent hypotenuse. Tangent, and I'm going to explain all of this stuff to you in a minute. Again, you could abbreviate opposite, adjacent. So let me just give you a second to fill in those fractions. Scroll this up a little bit. Not the way bottom. So your sine, cos, tan buttons that you see on your calculator, what we're really looking at is your 2 sides of the triangle. you guys all know what the hypotenuse of a triangle is. That hasn't changed. It's the longest side across from the right angle. We've got to get into clarifying, which is the next thing we're going to talk about, which is what we consider the opposite side. What is the side we consider the adjacent? Now, one other thing, you can see I got more peeking out the bottom here on the slide for you. There is a little saying to help you remember all these crazy fractions, like sine is opposite hypotenuse, cosine's adjacent hypotenuse, tangent, opposite, adjacent. SOH-CAH-TOA is how we say that. So let me give you a second to write that down next to your little star there. Let me explain the saying to you. So a lot of times you can just write SOH-CAH-TOA at the top of your paper and work off of it. Because what this is telling you is that sine is the opposite side, the O for opposite, over the hypotenuse. So it's telling you what sides. That's what this little saying is doing for you. The C stands for cosine. Cosine. That's a sloppy cosine, sorry. That's your adjacent side, and then H, of course, hypotenuse. And then our third trig ratio we're going to cover, tangent, TOA. That's your opposite, O for opposite side, over the adjacent. So the letters stand for the sides. So sine's opposite hypotenuse, cosine's adjacent hypotenuse, TOA, tangent, opposite, adjacent. So you'll see me be writing SOH-CAH-TOA a lot. As long as you can spell it correctly, this is a really easy assignment. So let's practice, super easy. Label hypotenuse, opposite, etc. Now I'm going to start with the easy. Hypotenuse. You know what the hypotenuse is. That hasn't changed. That is the side across from your right angle. That's always the same thing. No magic there. Now, you have to be conscientious. Notice it says from angle A. So they're going to tell you which specific angle you're working from. So now I'm going to label opposite and adjacent. Let me scroll this up a little bit. From angle A. So angle A, the side straight across from it is your opposite. The side next to it is the adjacent. And again, you have to look at which angle you're labeling from super close, because it might change. If it said C, C, this would now be the opposite of C, and this would be the one next to C, the adjacent. Hypotenuse never changes. That's the same thing on all of them. But the opposite and adjacent are dependent on what angle they tell you. So the first thing, or the next thing I should say we're going to do is practice labeling these sides. So flip the page. Now, you might need your calculator for this in case we have to reduce any fractions. Okay? So find the sine of S, the sine of R, write as a fraction, simplify your answer. Okay, so I'm going to do the S in purple. Now, sine. So I'm thinking about my SOH-CAH-TOA. So I know sine, of course, is your opposite over hypotenuse. All right, I got it. So from S. So super easy. Opposite of S is the side 63. You know it. What's the hypotenuse? 65, the longest side. Got it. Check really quick. Does 63 over 65 reduce? Do we know how to reduce fractions on your graphing calculator? Yes, no, yes, no, no, no. Okay, I think so. It does not reduce, just for the record. Okay, let's do now R. So sine of R. Okay, hypotenuse. Is the hypotenuse still the same? Yeah, that never changes. I'm going to cheat and fill the hypotenuse in first. Okay, but I got to look closely from angle R. What side is opposite of R? The 16. And then just check in your calculator, does 60 over 65 reduce? It does not. Circle it. We're done. So two sides of the triangle. That's what trig ratios are. It's that easy today, my friends. Just make sure you pick the correct sides. All right, let's mix it up. Cosine now. Okay. I'm going to do U in the red. So cosine. Remember, CA. So think about my SOH-CAH-TOA. So I'm thinking about adjacent next to hypotenuse. So I'm just thinking about my SOH-CAH-TOA. There's our sides. So So I'm going to do cos of u first. Okay, so of course, you know, hypotenuse. I'm just going to label it. That doesn't change. That's the easy one. Now, adjacent. Which side is adjacent to you? The 24 or the 18? Which one is next to you? The 18. So I'm going to have 18 over 30. Does 18 over 30 reduce? Yeah. Sure does. What goes into both of them? 2. You need to go bigger. You are right too, but I can go bigger.
6.
6, go bigger. 6 goes into it. How many times? 3 over 5. Got it. Now they want you, of course, to do W. Okay, let's do cos of W. We got it. Hypotenuse is still the same. I'm just going to cheat and fill that in. Make that easy. Okay, W. Which side is adjacent next to W? Is it at the 18 or the 24? 24 is next to it. Got it. Reduce it for me. What's 24 over 30? 4 over 5. And we're done. I love this stuff. I could do it all day. So we practice sine, we practice cosine. No shock here. You know, I'm kind of predictable in my old age. Let's do tangent. Okay? So remember, TOA. That's the last SOH-CAH-TOA, the last word in that little phrase. So I'm looking for my opposite side and adjacent. All right, we got it. So first we're going to do S. I'm going to do that one in red. Okay, so first thing I'm going to look from S. I want the opposite side. What side is straight across from it? 80. Got it. Next question. What side is adjacent to it? Are you using the 18 or the 82? I'm using the 18 because what's 82 really? Hypotenuse, which we don't need the hypotenuse, so I need my adjacent side, which is the 18. And of course that fraction reduces, they're both even, blah, 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 you can reduce it. 2 goes into both of them, 40 over 9. Okay, now we're going to switch it up a little bit. We're going to do from R. I'm going to do that one in purple. So again, I need opposite. So that to me is the easiest side. Opposite R, straight across, 18. Now, what side is adjacent to R? What are you using for the bottom number? 80. Because 82 is our hypotenuse. We don't need that for tangent. And of course, reduce it. 9 over 40. Got it. Any questions on those? All right, get ready. We're going to use our calculators now. Okay? So, notice, this is why I harped at you about your calculator mode. Your angles are in degrees. Radians on your calculator is another way to measure angles. You'll get into that more next year. Degrees for us. Find the value of x, etc. Now, not 30, not a 30, 60, 90. My shortcuts are not going to do anything for me. I have to use a trig ratio. First things first, we have to figure out what trig ratio, sine, cos, or tan. So I'm going to label the sides, mine are in blue of course, from my angle. So they gave me the opposite side of 11, and then they gave me this side right next to it, adjacent. Well, which trig ratio, sine, cos, or tan, had opposite adjacent? Tan, TOA. SOH-CAH-TOA, tangent, opposite adjacent. So I'm going to do tan. So tan of 32 equals our opposite side over adjacent. So there's the geometry setup. Now we're going to do some algebra. So we got to solve this equation for x, and we're going to use our calculator. We're going to get a decimal answer. Now, nobody loves a fraction in here. Let's clear out the denominator. I'm going to first multiply each side by x. So that's going to get rid of these. So I'm down to this, x times tan. You don't have to put the dot for the multiplication. I just put it in there for dramatic emphasis. Now, from here, I could really go to my calculator to finish this one, but you know I love to write work in here, so I'm going to. What cancels out times? Division. So I'm going to divide by the tan of 32 degrees. And I know you guys know that to solve equations. You're great at that. So here we go. I'm going to pull up the calculator. I am literally typing this in. I'm going to hit 11 divided by tan 32. Here we go. 11 divided by, I'm going to hit tan 32. You can close up the parenthesis or not. Since I have nothing else to type in, you don't have to, you'll get the right answer. So I'm going to round it to the 10th. I'm going to put 17.6 for it. Got it. So this is why it's important your mode is in degrees. If you had your mode in radians, you get every single one of these wrong. Nobody wants that, okay? Any questions on that guy? Love this stuff. I kind of miss proofs though. Okay, find the height of the lamppost to the nearest inch. Hopefully you can kind of see that white triangle over here. Now, kind of the same thing. We first 70, not a special triangle. I first have to figure out from the given sides if I'm doing sine, cos, or tan. So let's label our sides. Well, the height is the opposite side, 40. Would you classify that as the hypotenuse or adjacent? Adjacent. Now, clearly, I must be on a love of tangent here today on this because we've got opposite adjacent again, so I'm going to do TOA tangent. So tan of 70. And then, of course, remember the sides. You have opposite first, so I have to put the H first, and then adjacent next. I like this one. This is going to be easy to solve. As always, you want to clear out the denominator for your fraction. Just do a little times 70. Did I miss right? Oh, 40. Yeah, sorry. Tried to look in that little picture over there. 40. There we go. Let me switch it over here too. 40. 40. And I'll show you how to punch that guy in. Times 40. Okay. There we go. All right. I like this one because less work. Notice H is already alone over here. So all I have to do is grab my calculator and type this in. I'm going to do 40 times the tan of 70. There we go. 40. Put this in. Now, you don't even have to hit the times symbol. It's going to know it. I'm just going to hit tan. And again, you don't have to close up the parenthesis. You're not doing anything after it. And it says to round to the nearest inch. So whole number. Round that to the nearest whole number. What are you putting? 110. So I'm going to label it 110 inches for my final answer. I almost think this is easier than some of that 30, 60, 90, all those trig ratios, all the special triangle ratios. Hit it, Sophia. Oh, okay, so do you have a graphing, Sophia? Yeah. So look at, in your mode button right next to second, right here, degrees. Just select it and hit enter. And that should do it for you. All right, flip the page. Here we go, just different ones, okay? All right, word problems, but honestly, I don't think these are bad for word problems when you have the picture. You want a string cable to make a dog run from two corners of a building as shown in the picture. Write and solve a proportion using a trig ratio to approximate the length of the cable you need. Ooh, that's wordy. All right, so again, same thing. I'm going to figure out, is it sine, cos, or tan? 35. I regret the green. That doesn't show up very well in the picture. So again, we're looking at the sides, labeling the sides from the 35. So it looks like they gave you the opposites, 11. And what are you classifying x as? Hypotenuse. Across from the right angle or longest side. Okay, what trig ratio? Finally, we're off tangent. What trig ratio is opposite hypotenuse? Sine or cos? Sine. So I'm going to get fancy now, and I'm going to do sine of 35 degrees. And again, make sure you have the sides in the correct order. Remember, it's SOH, S-O-H. Opposite first, and then hypotenuse. Now, again, there's the geometry. I'm just going to use my algebra solving skills. Let's get rid of the fraction. Nobody loves a fraction in here but me. Now, from here, honestly, I could go to my calculator because I know to get x alone, how are you going to eliminate sine of 35? Divide it. So I just right now go to my calculator and I type in 11 divided by sine of 35. You know I love to write work though, so I'm going to write it. I'm going to divide by the sine of 35. Okay, let's punch it in. Doesn't say what to round to, so I'm going to make it easy and just round to the 10th here, okay? So I'm going to do 11 divided by sine. Got it. So let's round it. Let's say 19.2. Let's go with. And it's a word problem. I feel like we should label our answer. What units are you measuring in? Feet. Got it. Do this all day. All right, here we go. One more little triangle, and then we're going to talk some vocab. I promise you, I know the notes are kind of long today. They're shorter tomorrow. Find the length of x, round to the nearest tenth. Okay. So again, no special triangle. 50, 40, 90 is not something. So I'm going to use a trig ratio. So they gave us our hypotenuse here, our side across from the right angle. Okay, is x, I'll give you 50-50. Do you classify x as opposite or adjacent? Adjacent. What trig ratio has adjacent and hypotenuse? A and H. Cos. Cos. So we're going to do cos of 50. Let's set it up adjacent first, so x, hypotenuse on the bottom. Now, a lot of you from there don't have to write anything else. You could go to your calculator. Because to get x alone, how are you getting rid of over 15? Yeah, multiply. So I can't even say I would write this on my own. I would just do times 15 and go to my calculator. All right, punch it in. You're probably tired of watching me punch it in. It says round to the 10th. And you get 9.6 for the win. Any questions in that? Okay, we're going to start, I should say, talking about in some of these word problems. It's not too spicy today, I promise, about angle, this looks crazy, angle of elevation, angle of depression. So there's nothing for you to write in your notes here. We just have to look at these pictures for a minute. So if you look up at an object, the angle your line of sight makes with the horizontal is called the angle of elevation as you look up. If you are looking down, they call it the angle of depression. Now, let's throw back. You know I love to review stuff. I can't help myself. Guess what? These angles are congruent. What type of special angles are those on your parallel? Those dashed lines are parallel lines, alternate interior. So they are going to always be congruent, just for the record. So you're going to start seeing in some of the wording of these story problems, etc., they're going to talk about angle of elevation, bottom looking up, depression, top looking down. They're really the same though, just for the record. So here we go. The picture's drawn. We don't have to do anything fancy really. You are skiing on a mountain with an altitude, a height of 1,200 feet. The angle of depression is 21 degrees. About how far do you ski down the mountain? So they have everything labeled for you. I'm just really going to kind of focus in on this right triangle here that has all the numbers on it. Obviously, 21 degrees is not a special triangle, so I'm going to use the trig ratio. So let's take a look here. So they gave you the opposite side, an x. How do you classify x, adjacent or hypotenuse? Hypotenuse. Across from your right angle, so that's our hypotenuse. So what trig ratio has opposite and hypotenuse? Sine. So I'm going to do sine of 21. Opposite is that 1,200, hypotenuse. So there's the geometry setup, nothing crazy. We're going to get a big answer for this one. I'm going to multiply by x, of course, to clear my fraction. Now from here, I'd probably go straight to your calculator. Because to get x alone, how are you going to get rid of times sine of 21? Divide. So really, I probably wouldn't necessarily be writing this on my actual work. I just know in my calculator I'm going to do 1,200 divided by the sine of 21. And like I said, you get, I think it's kind of a big answer. I rounded to the 10. Punch it in. What do you got? I hear it. 3,348.5. Got it. Anybody a skier in here? I'd probably break my leg. Any questions on that? All right. Final problem. Oh gosh, but we got to draw our own picture. So here comes my artistic skills. Get ready. A rope staked 20 feet from the base of a building goes to the roof, forms an angle of 58 degrees with the ground to the nearest tenth of a foot. How long is the rope? Whew, wordy. Okay, let's start with the rope stake 20 feet from the base of the building. Here's my building. 20 feet from it. Here's my rope staked. Now, you can clearly see we're making my right triangle here. Okay. Now I'm going to keep on reading. Okay, forms an angle of 58 degrees with the ground. So is the 58 degrees the top angle or the bottom angle? Bottom, with the ground. The ground's on the bottom. Got it. Okay, keep on reading. To the nearest tenth of a foot, how long is the rope? So here's the next question. What side is the rope? Is it the hypotenuse or the vertical one? Hypotenuse, because it's from the stake to the top of the building. So I need you to find me that hypotenuse. All right, well, let's see. What trig ratio are we doing here? So, of course, we already said that's our hypotenuse. What do you classify 20 as? Opposite or adjacent? Adjacent. So, of course, adjacent, hypotenuse, that's our cosine. Adjacent over hypotenuse. So there's our geometry setup, easy peasy. I'm going to clear the fraction. Nobody loves a fraction. And from here, most of you probably aren't writing anything else. You're on your calculator because you know to get x alone, you're going to divide that cos of 58 off. You know I love to write work, so I'm going to write work. So in your calculator, you're doing 20 divided by cos of 58. I rounded to the 10th. You round to whatever. Love it, 37.7, and I'm going to label, we're in feet. Got it. Any questions on the trig ratios? Hey, it's everybody's favorite. Let's do some standardized tests. All right, these are super easy. Remember, I'm trying to keep you out of STP math. These are super easy. It's incredibly wordy. The line on the XY plane above represents the relationship between the height in feet and the diameter x. Okay, yeah, architecture, great. How much greater is the height of a Doric column that has a base diameter of 5? So looking at that guy. Then a height of a Doric column that has a base diameter of 2. So, well, let's get the height. So I'm going to start at 2. If you're at 2, of course, the height is 14. If I'm at 5, the height is 35. So it's asking you how much greater. All right, well, from 14 to 35, how much greater is 35 than 14? 21. There we go. That was easy. I didn't really have to do much. You just had to, get the numbers from the graph. Easy again. And you know I love square roots. X is greater than 0. Which of the following is equivalent to the given expression? You should be able to do that. No work. Anybody pick C or D? I don't know what to tell you. What's the square root of 9? 3. So I know it's A or B. Which one? B. I'm hearing both. What happens to square root and squaring? What do they do to each other? Cancel. So is it A or B? A. We don't even have to do anything. Okay. Those weren't bad. Those weren't bad for today. At least I hope not anyway. Hope not. Hope not.